Hello, and welcome to this YouTube tutorial video on creating an AI system. My name is Abbas Khan, and over the course of this video, I'll be showing you how to create this system from scratch. Now, before I move over to Unity, I'd like to outline a couple of points. Firstly, for this tutorial, I'll be using Unity version 5.6.0. If you have a different version of Unity to this one, then I can't guarantee that the system will work, as I've only tested it on this version. Should you wish to download the same version of Unity, you can get it from the Unity website. Next, I'd like to outline the order of events for this video. To begin with, I'll be setting up the Unity project for version control so that you can view the complete project, and I'll also be importing some standard assets to help speed up the initial workflow. After that, I'll be setting up the environment by creating a few auto sources such as ramps and walls to give our AI a bit of a terrain to navigate around. Next, I'll be setting up the player with the default first-person controller found in the standard assets. After that, I'll set up the enemy, the nav mesh, and layer for the player. After all the setup and everything is done, then we'll finally start to create the script. The script has four main components: detection by vision, detection by proximity, predetermined movement, and random movement. But we're looking to implement all four of these features. Now that we've sorted that out, let's move over to Unity. Okay, so let's start with Unity and create a new project. Make sure that you set up the project for a 3D environment, as our AI system is for 3D environment. So I'm just going to create a new folder, a desktop folder project, and I'll call it AI tutorial. I'll give the project the same name. Now, if you've got the standard assets already from working on a previous project, you can go ahead and import it here if you want. I'm going to import it later, as I have a custom Unity package that takes out some of the unnecessary components. This way the project size isn't as big. Alright, now go ahead and click create. Okay, so now I'll go ahead and drag and drop the asset package. This package contains the first-person controller and other components that I'll be using to speed up the initial workflow. I'll include this asset package on Bitbucket so that you can use this as well, should you wish to. Alright, now that's sorted, I'll go ahead and set up the project for version control. If you go to Edit, Project Settings, Editor, and make sure two things are set. Firstly, the asset serialization is set to force text, and secondly, the version control is set to show metafiles. Okay, now let's go ahead and start to create a little level. To begin with, I'm going to make a plane to serve as our ground. Just scale it up a bit. Let's add a material onto it as well. I'll go with a dark grey. Now let's get the player all set up. Go ahead and drag and drop the first-person controller prefab into the scene. Drag him up a bit so he doesn't slip through the ground. Don't forget to delete the main camera, as the prefab already has a camera with it. Now, despite this being a first-person demo, I'll still create a player model just so that we can easily see the player within the scene view. For this, I'll be using a capsule for the body and a sphere for the head. I'll be childing these objects into the FPS controller so that it moves together with the camera. Let's make some materials for our player and the enemy. I'll go with blue for the player and red for the enemy. Also, don't forget to zero out the transform of the capsule, as this aligns it with the camera. So to make the enemy, I'll just duplicate the player model and put the enemy material on it. Next I'll set up the layer for the player. Click on the player and go to layer and add a new layer called player and assign the object and all its children to it. Next I'll create a cube to serve as our obstacle object that we can resize and shape as we wish. I'll also create a material for it. I'll go with orange. After that, we can go ahead and finish up setting up our enemy by adding a navmesh agent to it. For this tutorial, I'll modify the area mask to just have the walkable area. I'll also change the stopping distance to 4. We'll need this later on for the script. Okay, after that, we can move on to creating the level. I'll rejoin you after this is done. Alright, so this is the level I've built. It's got a couple of borders, ramps and walls. This gives the AI more objects to navigate around, which allows for a proper demonstration of the AI's capabilities. I've also created a second ground area, which is a lava area, where the enemy AI will not be able to travel upon. I opted to add a dark orange material for the lava ground. Now, before we move on to creating the nav mesh, let's go ahead and tidy up our hierarchy by creating an empty game object to store our environment objects into. This will make our hierarchy a lot more manageable. Next, I'm going to change the enemy AI's stopping distance. I'll set it to 1, as this reduces the distance between the target destination and when the enemy AI will stop. After that, we need to set up the environment to make the nav mesh. Set all the environment objects static by clicking on the environment game object and clicking the static button in the top right. Make sure to change all the children. With that done, head to the navigation tab through the window and then down to navigation. The first thing I'm going to do is click the lava ground and change the navigation area on it to non-walkable. I'm also going to select the borders and walls and mark them as non-walkable also. For the purpose of this tutorial, I'll be using the pre-assigned navigation areas, but you can also use your own navigation areas in the same way. Now, let's go ahead and click Bake. That's strange. I'll go and figure out what's wrong and rejoin you once it's fixed. Okay, so I believe the issue was only visual. I simply moved the ground down slightly to let the nav mesh overlay display properly. With that done, I'm just going to create a couple of prefabs of the player, enemy, and the obstacle. Alright, now that everything is set up properly, let's go ahead and create the script. However, before we get into the scripting, I'd like to visually show the types of mechanics that we'll be creating. Now, as stated at the start of the tutorial, there will be 2 movement types for this AI. The first is a predetermined waypoint patrol, whereby the enemy will move along a set path. Upon reaching the final point in the path, they will return to the original point, and in doing this they will complete the loop, which will repeat unless they detect the player. The next type is more random, in that a point is generated at runtime, within a sphere around the enemy. Upon reaching the point, a new random point is generated and the previous point is discarded. This will continue to occur unless they detect the player. Next, the two detection types. Firstly, there is a detection through vision. This works by calculating an angle between a line from the enemy's local forward direction and a line between the enemy and the player. If the angle X in the diagram is less than 45, which is the field of view of the enemy, then the player is detected. However, if the angle is greater than 45, then the player is not detected. The other detection mode is proximity based. If the player is very close to the enemy, such as in the diagram, then they will be detected. It simulates the real world as you can sense another person near you through sound and movement. With that said, let's move over to Visual Studio and create the script. Alright, to begin with, let's create a region for our variables by using #region and #endRegion. Next, we'll need a public transform to hold our player position and a public layer mask for our player's layer, which will be used to help reduce the amount of objects the enemy will scan. After that, we can add a public navmesh agent, but to add that, we'll need to add the using Unity Engine.ai line at the top. We can also get rid of the unnecessary using calls. Next, add a private int for the patrol type and a private array of vector 3s. Give the array a default size of 3. Only a few more variables will be needed. Firstly, a private int to serve as an iterator for the patrol route movement, a random movement range which will determine how far away the next point is generated, which will be set at 25, and a vector 3 to hold the current point in the chosen patrol type. I'll also add a few comments for these variables as well. Okay, let's set up the start function so that the predetermined patrol will set the first transform in the array to the enemy's start position. To do this, we have to first check if we are using the predetermined path by checking the patrol type. Then we can set the first index in the array equal to the transform's position, as the script will be attached to the enemy. I'll also add some comments. Next, we can set up the update function. Although we have not created all the functions yet, we can still set up update and then implement the functions later. So to begin with, let's check if either detection by vision or proximity is true, then chase the player. Otherwise, if the detection by vision or proximity is false, then perform the patrol. But with this function, we need to pass in the patrol type as a parameter, so that we can differentiate which type of patrol will be performed. Now we will have to serialize some fields so that we can edit and see them in the inspector window. To do this, we have to add the tag serialize field in square brackets just before the variable declarations. In this case, we are doing this for the patrol type, patrol route, and random movement range variables. Finally, let's create the functions that update requires. For detection by proximity and vision functions, they require a Boolean value to be returned. For now, we can just return false. Next, we can also create the player chase and perform patrol functions. The perform patrol function takes in a parameter, so be sure to include that. Next, there's one more function we need to create, and that is the random point generation function, which is a function that returns a Boolean. It also takes in a couple of parameters. Firstly, a vector3 that is used to determine the origin point to generate the random point around, a range to determine how far the random point can be, and push out a vector3, which is the point itself. As the function is a Boolean, it has to return a Boolean, which in this case will return false. We also have to push out the result as well, as it is marked with the out keyword. In this case, we'll just push out result as vector3.0. Okay, let's set this function up. So first we need to create a local variable, a vector3, to hold our random point that is generated within the sphere. Next we need another local variable, a navmesh hit, which we will use to check whether the point is on the navmesh. The next line is the check. If the hit is on the navmesh, set the result equal to the hit's position and return true. There's no need to worry about the lines after, as the return keyword ends a function's execution, so the lines after won't be executed if this is the case. Next we can set up the player chase function, which is one line of code. Enemy.setDestination, and then within the parenthesis, player.position. This sets the enemy after the player. As the update function runs once per frame, they will effectively chase the player as he moves. Next, we'll move on to the detection methods. starting with proximity. To begin with, create a local array of colliders and set that to be populated by any object that enters the overlap sphere around the enemy. In this case, we specify a layer mask, so only the player will be populating the array. Due to this, we can then simply ask if there is anything in the array, return true, as we know it can only be the player. Otherwise, return false. Now let's do the vision detection. Let's create a local raycast hit, which we will use for our enemy's detection. Next, create two vector 3s, one for the direction of the ray between the player and the enemy, and the other for the forward direction of the enemy. After this, calculate the angle between them and store the result in a float variable. This value is absolute. Then, if the raycast between the enemy and the player is possible, check if the position of the hit is equal to the player's position and the angle is less than 45. If so, return true. Otherwise, return false. Let's now do the patrol function. Firstly, we need to determine whether the movement is random or predetermined by checking the passed-in variable's value. 1 is for predetermined and 2 is for random. Let's do the random movement first. So if the enemy's remaining distance to its destination is greater than the stopping distance, then continue on the current destination. But if it's less than or equal to the stopping distance, Then call the generate a new point function and set the destination to that point. Next, we can do the predetermined movement. Start if the enemy's remaining distance to its destination is greater than the stopping distance, then continue on the current destination. But if it's less than or equal to the stopping distance, then, depending on the value of the patrol route index, increment the index by 1 or reset to 0 if it's already pointed to the last waypoint. Then set the destination of the enemy to the point in the patrol route array specified by the index. With that done, we've completed all the mechanics for the script. Now that we've completed the mechanics for the script, I created a second script which is the same but contains various debug functions, comments, and slightly modified variable names. Essentially, it's just a tidier version of the script. I'll leave both scripts in the project so you can use whichever one you wish. Now with that done, let's move over to Unity and add the AI script onto the enemy. Upon doing this, you'll see a couple of empty slots which we have to fill in. Firstly, let's assign the nav mesh agent in the enemy AI script. You will then see a sphere and a few lines being drawn out from the enemy. This is the onGizmo selected function. Next, we can assign the layer mask variable to the player layer and also drag and drop the player in. After that, we've got the control root array that can be modified in Editor by simply modifying the X, Y and Z values. You can also increase the amount of points as well, but keep in mind the first point will move to the original start point of the enemy. Finally, we can set the control type to either 1 or 2, which is predetermined movement or random movement. I'll quickly show off the different mechanics in action. Let's begin with the predetermined movement. As you can see, the enemy moves around the world, passing through each of the waypoints and then returning to the start point. We can also see a visual representation of the vision detection in the in-editor gizmos. Okay, now let's try random movement. By changing the control type, as we can see, the enemy moves to the small green point that appears. This is the random point that was selected within the range. Upon reaching it, the enemy then moves to the next random point, as shown. Next, I'll show the detection, but first I'll turn off the control and player chase functions to help with the demonstration. As you will see, when the player moves into the enemy's line of sight, the console will be spammed by the print messages that the player has been detected. After that, I'll show the proximity detection. As you will see, the player will be just outside the sphere of detection, and as such won't be detected. However, upon entering the sphere, the player will be detected, as shown by the print messages that will be in the console. Finally, I'll show the player chase function. As you will be able to tell, both of the enemies chase the player, but they can lose the player should he move outside the range of the raycast, which can be modified in the script. That concludes the demonstration. With the demo concluded, this completes the tutorial. The following pages show the links that were used to help create the system. I'll leave these in the description for you to read should you wish to. This concludes the video. Thanks for watching.